Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be using models to multiply and divide integers. Let's start with modeling multiplication. Since multiplication is repeated addition, we can use counters to model that multiplication. Remember, a negative sign can also mean opposite. We'll be using that fact in some of our models in just a moment. So in example 1, it says complete the sentence for each multiplication problem and then model and solve. So in problem A, our multiplication problem is 2 times 3. So this literally means we want two groups of positive 3. So I'm going to make 3 positive counters and make 2 groups of that. Now if you count up your total, you're going to get positive 6. Problem B, we have 2 times negative 3. So this literally means 2 groups of negative 3. So this time I'm going to make 2 groups of negative 3. And that would be a total of negative 6. Now, when your first number is negative, that means opposite. So in this problem, we have the opposite of 2 times negative 3. So what this literally means is the opposite of 2 groups of negative 3. So I'm going to start out by making 2 groups of negative 3. But in this problem, we want the opposite of 2 groups of negative 3. So if I were to take the opposite of all of these counters, that would give me a total of positive 6. Now let's summarize these findings. So in example 2, A, it says when the signs were the same, in other words, problem A and problem C. In problem A, we had a positive times a positive, and we got a positive. In problem C, we had a negative times a negative, and our answer was also positive. So whenever the signs are the same, when you're multiplying, you're going to get a positive. Now, when the signs are different, like in problem B, your answer will always be negative. So in example 3, it says tell whether the product for each of the following would be positive or negative. Do not solve. In other words, they don't want you to multiply this out. They just want you to say, would the answer be positive or negative? So in problem A, we have positive 25 times positive 32. The signs are the same, so positive. I'll just abbreviate that. In problem B, we have negative 48 times 27. So here the signs are different, so these would be negative. Pause the video and try problems C and D on your own. When you're done, press play and check your answers. All right, welcome back. On C, they were both negative, so I put positive. And on D, the signs were different, so I put negative. Now, we can also model division problems using counters. These example 4, I drew the counters for you just to save a little bit of time. So in problem A, we want to take 9 positives and divide them into 3 groups. So here, I want to put positives because the 9 was positive. That's the number being divided. Then I want to divide this into 3 groups. So there's 1 group, 1 group, and 1 group. Now our answer is how many are in each group? Well, there are 3 positive counters in each group. So 9 divided by 3 would give me positive 3. Now in B, we're taking negative 9 counters and dividing it into 3 groups. So negative, 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 negative. And I want to divide this into 3 groups. And that gives me how many are in each group? Negative 3. Excuse me. In problem C, we have negative 9 counters here, but this time we're going to divide them into the opposite of 3 groups. So I'll start out with my 9 negatives. Then I'll divide them into 3 groups. And then because that bottom number is negative, I must take the opposite of each one of these. And so that would give me positive 3 for an answer. So negative 9 divided by negative 3 is positive 3. So the same rules for multiplication are the same for division. If the signs are the same, like a positive divided by a positive, we get a positive. A negative divided by a negative gives us a positive. If the signs are different, we'll get a negative answer. All right. Now, we can also use number lines to model multiplication. So let's look at example 5. It says, model the following problems with a number line. Begin your model at 0. So in problem A, we have 2 times 3. So what this means is we're going to take 2 jumps that are 3 units each. 2 jumps that are 3 units each. So if I start at 0 and I go 3 units, that would be my first jump. And then I would take 1 more jump. Wherever you land, that's your answer. So positive 2 times 3, positive 6. All right. In problem B, we have 5 times negative 1. So now we have 5 jumps, and they're negative 1 units. So starting at 0, I want to go, my first unit is negative 1, and I want to do 5 jumps. So I did 1 jump, 2, 3, 4, 5. Wherever you end up, that's your answer. So 5 times negative 1 is negative 5. All right, in problem C, we're going to do 3 jumps of negative 3 units. So starting at 0, my units are negative 3. So there would be 1 jump, 2 jumps, and 3 jumps. Again, wherever you land is your answer. So this would be negative 9. You know, I should probably label the size of these. In problem A, they were positive 3. In problem B, each jump was negative 1 unit. And in problem C, each jump was negative 3 units. All right, so this time we're taking the opposite of 2 jumps of negative 3 units. Because our first number is negative this time, that means opposite. This is the opposite of 2 jumps of negative 3 units. So let's draw our negative 3 units. There's 1, and it said to do 2 jumps of that. All right. Then where we landed was at negative 6, but that's not our answer because it said to take the opposite of that. So that would land me over here at positive 6 if I take the opposite. So negative 2 times negative 3 would give me positive 6. So again, a negative times a negative gives you a positive. All right, in example 6, it says find each product or quotient. You can use a model or test the patterns you have discovered. So what I'd like you to do now is pause the video, try each one of these problems. When you're finished trying them, come back and check your answers. All right, welcome back. Let's see how you did. On problem A, the signs were different, so my product was negative 30. In problem B, the signs were also different, so this time my product was negative 20. In problem C, the signs are the same, so I know my answer will be positive 32. Problem D, the signs are different, so I know my answer is going to be negative. In problem E, the signs are different, so I know my answer is negative. In problem F, the signs were different, so my answer is negative. In problem G, the signs were the same, so I know my answer is positive. And in problem H, the signs were the same, so I know my answer is positive. Please take a moment to correct any problems that you might have gotten incorrect. Now, in example 7, they're going to give us a model and they're going to ask us the equation that's modeled. So the first thing you want to do is check in problem A, where does the model start? So it starts at 0, and then it's jumping -4 units. And then there are 3 jumps. So this is 3 jumps of -4, and it lands at -12. So that is our product. All right. Now, in problem B, you have to be very careful because problem B does not start at 0. It starts at -8. So this time we need to write down the -8 plus there are 1, 2, 3, 4 jumps of +2 each. So this is -8 plus 4 times +2, and it lands at 0. So that's our solution. Now, another way you could see this written is -8 plus 4 times 2 equals 0. It all means the same thing. All right, that concludes today's lesson, using models to multiply and divide integers.